Good evening. My name is Mr. Calloway. I'm the Head of Science at the Gainsborough Academy. If you're watching this, you're currently considering your options, and unfortunately, science is not one of them. Along with English and maths, it's one of the three subjects that the government say you have to study all the way up to the end of year 11. So you will be taking science, and you will be achieving 2 GCSEs in it. It's broken down into 3 subjects: biology, chemistry and physics. And at the end of year 11, you'll have 6 exams, 2 in each of those subjects. The exams are worth 70 marks. They take an hour and 15 minutes each. Once they're finished, they get marked, and you get a total score, which is then used to give you 2 GCSE grades. The exam board we use is AQA, and the specification is Combined Science Trilogy. So if you're using a revision guide, or you're using the GCSE Bite-Size app, which is available for free on your phone, that's the exam board you want to look for to make sure that you're revising the correct content. The biology that you'll cover over the next few years is broken down into 7 topics. It starts with cell biology, where you look at the basic building blocks of all life. Then move on to organisation, which is about organs and systems in the body, specifically the digestive system and the respiratory system. The topic on infection and response, which is quite topical at the moment, is about how science has discovered that it's microorganisms that cause infectious disease and how we can best combat these to maintain good health. Bioenergetics is about how living things get energy. So you'll look at photosynthesis and how plants get their energy from sunlight, and then how that moves through food chains, and then how cells use respiration to get the energy they need. Homeostasis and response is about how your body maintains constant internal conditions. This could be, say for example, how your body stays warm on a cold day, or how it cools down on a hot day. Inheritance, variation and evolution is all about genes, how genetics tells our bodies what to put where, and then how these genes can mutate and change so that when they're passed down to successive generations, there can be subtle differences that lead to changes through natural selection, and this can even lead to new species emerging. Finally, you tie all these ideas together with a topic called ecology, where you look at how plants and animals and even microorganisms depend on each other for the resources they need. Chemistry is broken down into 10 topics. That doesn't mean there's more chemistry to learn, it just means that some of the topics are shorter. It starts very much like biology, with the foundational ideas, the basic things you need to understand. In this case, atoms. What are they made of? And what different types of atoms are there? The periodic table is just a list of all the different types of atoms, but it's been arranged in a particular way for particular reasons, and that's one of the things you'll look at first. Then you'll go on to how atoms can bond together and how this forms different materials, and how this gives rise to different properties. So for example, how come copper is a good conductor of electricity, but table salt isn't? Then you'll look at quantitative chemistry, which just means making measurements relating to chemical reactions. And you'll see how to make precise, accurate measurements. The next few topics also involve a lot of measuring, but they're to do with changes that can arise during chemical reactions, the energy changes, so whether things get hotter or colder, and the rate at which chemical reactions happen. So you'll learn about how to speed chemical reactions up so we get the products that we want more quickly, but sometimes at greater cost. The organic chemistry topic focuses quite heavily on crude oil and the products that we get from crude oil, like petrol and diesel, but it forms the basis of a lot of the ideas that are used in modern medicine, veterinary science, and nursing. So if you're considering a career in those areas, that's one to pay close attention to. Chemical analysis is about identifying different chemicals to make sure that the thing you've made is the thing you're after. The chemistry of the atmosphere looks at how the atmosphere has changed over millions of years. But it also looks forward to the future to consider how global warming might affect the atmosphere and the Earth, and what challenges that might pose over the next few decades. And lastly, using resources looks at how manufacturers of products and the people who have to dispose of those products can do so in as environmentally friendly a way as possible. Similarly, physics starts with a basic topic that introduces the key fundamental ideas, in this case, energy. Energy has been studied very carefully over the past couple of hundred years since the Industrial Revolution, mostly because machines involve energy transfers. You then move on to electrical circuits, where we'll look at how energy transfers take place in circuits, and we'll make measurements of current and potential difference, and talk about how to build useful circuits that are applicable to real-world situations. The next topic is all about the particle model of matter, so we'll look at how particles behave in solids, liquids, gases, and why these are different. The next topic, atomic structure, often called nuclear physics, is the one where we look at ionizing radiation. Forces involves looking at how objects interact with each other. Waves involves energy transfers when no matter is moving or changing place, but energy is. And lastly, we'll look at magnets and electromagnets and how we can use magnets usefully and why you might choose an electromagnet and even how to build one. Now, across all three sciences, you will be developing your understanding of how science works. We don't do an individual how science works lesson, rather we teach this throughout the course. But the reason that science is one of the core subjects is that while English develops your ability to communicate and maths develops your ability to think logically, science is all about thinking critically. Can you tell the difference between good evidence and opinion? Can you take on new evidence and change your mind? Well, this topic, taught over the course of the entire GCSE, is all about that. And on the specification, it's broken down to 4 key areas. The development of scientific thinking is about your ability to ask those critical questions. Experimental skills, it's all about planning and implementing fair experiments. And there are 21 required practicals that you can be asked about directly on the GCSE. So there will be lots of opportunity for not just planning those practicals, but doing them, obtaining results, and then analysing and evaluating those results to decide what they do and don't tell us. And lastly, vocabulary is all about your ability to use the right words correctly so that you clearly communicate your findings. Now, studying science and taking it further than GCSE, taking it to A-level and even to degree level, can lead to lots of really interesting and well-paid careers. Some of the highest paid careers, like medicine, require science A-levels. But many professional scientists aren't really motivated by money. What they're motivated by is a passion, an interest in something. And that's why developing scientific skills is really important. Say, for example, you're really interested in dinosaurs or stars and planets or what's happening inside your body. Science is how we know. And what you're going to be learning over the next few years is how scientific ideas have developed over centuries to get more and more evidence, more and more data, more and more information to make our understanding of these things better. But it's not over yet. You can see here on this slide things that have been discovered literally in a recent week. And that's an ongoing story. Studying science is becoming part of that story. When you study science and contribute to it, you make new discoveries, and you too could be someone who generates a headline. We look forward to teaching you.